Now let's look at deep belief networks and see how they are built on top of RBMs. A deep belief network is a network that was invented to solve an old problem in traditional artificial neural networks. Which problem? The backpropagation problem that can often cause local minima or vanishing gradients issues in the learning process. A DBN is built to solve this by the stacking of multiple RBMs. So, what are the applications of DBNs? DBNs are generally used for classification, same as traditional MLPs. So, one of the most important applications of DBNs is image recognition. The important part to remember here is that a DBN is a very accurate discriminative classifier. As such, we don't need a big set of label data to train a deep belief network. In fact, a small set works fine because feature extraction is unsupervised by a stack of RBMs. Now, let's look at autoencoders. Much like RBMs, autoencoders were invented to address the issue of extracting desirable features. And again, much like RBMs, autoencoders try to recreate a given input, but do so with a slightly different network architecture and learning method. Autoencoders take a set of unlabeled inputs, encodes them into short codes, and then uses those to reconstruct the original image, while extracting the most valuable information from the data. What are the applications of autoencoders? Well, autoencoders are employed in some of the largest deep learning applications, especially for unsupervised tasks. As the encoder part of the network, autoencoders compress data from the input layer into a short code, a method that can be used for dimensionality reduction tasks. Also, in stacking multiple autoencoder layers, the network learns multiple levels of representation at different levels of abstraction. For example, to detect a face in an image, the network encodes the primitive features, like the edges of a face. Then, the first layer's output goes to the second autoencoder to encode the less local features, like the nose, and so on. Therefore, it can be used for feature extraction and image recognition. By now, you should have a good sense of deep neural networks. This concludes this video. Thanks for watching.